everyone, welcome back to another math video here with Mrs. Jockel. Today we are going to be completing lesson 10.8, which is estimating and measuring mass. So we're going to find out what mass is today, and let's go ahead and do that. So our Unlock the Problem tells us about Pedro. Pedro has a dollar bill in his pocket. Should Pedro measure the mass of the dollar bill in grams or kilograms? Well, we kind of need to know what these two terms mean because they might be new to us to hear. Because in our country, the United States, we typically don't measure mass using grams and kilograms. We measure weight using ounces and pounds. So I have on the left-hand side of the screen our customary units of measurement pointed out here that we measure using pounds and ounces. And 16 ounces is equal to 1 pound. So maybe you can ask mom or dad when you were born how much you weighed. On average, most babies weigh, maybe 8 pounds, 6 ounces. Or 7 pounds, 5 ounces. I know both Noah and Sadie, oddly enough, were 6 pounds, 14 ounces whenever they were both born. So when we measure in the United States, we typically are using our customary units of measurement. So when you go to the store and you're getting some produce, they have scales that you can weigh your produce because it might be $1.99 for a pound of apples. And so maybe you pick out 4 apples and you want to see how much they weigh to see about how much you're going to pay. Things that are larger, we would measure in pounds. So when we are measuring our own weight, we measure how much we weigh in pounds. If you step on a scale and you have a digital scale, you might see, something, I don't know, like Noah, when he steps on the scale, it says like 61.5. So that would mean 61 pounds and 5 ounces. Now, there is something larger than pounds and ounces, and that would be tons. And 2,000 pounds is equal to 1 ton. So when we are measuring things in tons, we're talking about really large objects. So we would measure, cars or trucks, boats, airplanes, large animals like elephants and blue whales. We would measure their weight maybe by the ton. But since we don't use tons as often, it's not always mentioned. But today we're not talking about ounces, pounds, and tons. Today we're talking about metric measurement, which is what every other country besides 3, pretty much, uses around the world to measure mass. So the gram is the basic metric unit for measuring mass. And then kilograms would be 1,000 grams. So you see my chart over here. For our metric system, we have grams and kilograms, and it takes 1,000 grams to equal 1 kilogram. At school, I had posters I would be posting to show that 1 grape is about 1 gram, and 1 pineapple is about 1 kilogram. So I always say think of grapes for grams and pineapples for kilograms. So that you could kind of estimate the weight of objects using grams and kilograms. I've seen other comparisons like a slice of bread, just 1 slice, could be measured in grams, but then when you have maybe 2 loaves of bread, that would be, equivalent to 1 kilogram. They show us here in our book that a small paper clip has the mass of about 1 gram. So when you think of holding a paper clip in your hand, it doesn't really feel like much weight at all. So grams are very small units of weight. Whenever you think of things that are very light, you would typically then measure those items in grams. Now, if we took 1,000 paper clips and had them in a a large box, the mass of all 1,000 paper clips would equal about 1 kilogram. So that's kind of the same comparison that I gave as grapes to pineapples. So 1 grape is about 1 gram, and if you took 1,000 grapes and weighed them, it would be, you know, maybe like a pineapple, which would be 1 kilogram. Okay? So when we think about Pedro, he has a dollar bill in his pocket. Would he measure the weight of it in grams or in kilograms? Now, when you think of holding a piece of money, a dollar bill, you know, it's not really weighing you down. Otherwise, our wallets would, you know, rip a hole in our pants. So I'm thinking that we're going to measure the mass of his dollar bill in terms of grams. Okay? Kilograms are going to be things that are a little bit heavier. All right, now activity 1 is a little difficult to do, I know, from home, and also for me because I don't have a balance scale just lying around my house. So we're just going to do the best that we can throughout this lesson here. But at school, we would have just explored a little bit with different materials from around the classroom and measured their mass in terms of grams and kilograms. And we would have practiced using a balance scale, as you see here in the picture. A balance scale is meant to do just that. It's meant to balance out whenever 2 objects weigh the same amount. So if you place an apple on each side of the scale, you know, about the same size apple, same type of apple, it should weigh about the same. So that means our scale would level out. It would be balanced. But let's say we had just 1 apple on one side, and on the other side we put a whole bag of apples, then the side that's heavier, the bag of apples, is going to go down, and the lighter object, which would just be the 1 apple, is going to go up on the scale. So it helps you to see objects that weigh more or less based on if the scale is balanced or not. So if we put 10 grams, because they want us to compare 10 grams to 1 kilogram. So if we put 10 grams on the scale, so imagine 10 grapes, okay? So if we put 10 grams over here and 1 kilogram, do you think that those are about the same? 10 grapes compared to 1 pineapple. Is that going to be the same weight? And obviously, you know, from our picture here, the balance scale is not balanced. So no, 10 grams and 1 kilogram are not the same. 1 kilogram is going to be heavier, which is why we see this side of our balance scale going down, and that's why I put the 1 kilogram on the left side. 10 grams are going to be lighter, so they're going to kind of go up a little bit on the scale because they are lighter than the kilogram. So things that are heavier are going to, because of the force of gravity too, they're going to pull down harder on the scale. So the pan balance here, or you know, the balance scale I call it, it is not balanced. So that tells us that these 2 objects are not the same in their mass. Okay, so not balanced. Okay, so 10 grams and 1 kilogram don't, oh my gosh. I need to go to typing class. I can't type on my computer for some reason. Okay, so they don't have the same mass as one another. And remember, from what I told you up top here, it would take 1,000 grams to equal 1 kilogram. We were just talking about 10 grams, so it certainly would not be the same mass at all. All right, over to the next page. Activity 2 is also going to be difficult to do because they wanted us to explore the mass of different objects from around the classroom. They wanted us to estimate the mass of, you know, how much we thought they weighed and then actually weigh them on a scale. I don't expect you to do this at home because I'm not even able to do it from my house either. So let's just take a minute or two to look at the objects, and then I think we could kind of estimate which objects would be heavier and which ones would be lighter. And we could try to put them in order down at the bottom from greatest mass to the least. So we have a crayon, a stapler, an eraser, a marker, a small notepad, and scissors. So when I think of a small notepad, I think of just like those little, like, honestly, like teeny tiny rectangular ones that have like the spiral holder on it, and you know, might, I don't know, get them in your Easter basket, or I don't know, something silly. So I'm not thinking of like a notebook that we use for our writing or like a math notebook or anything. So when we look at these objects, most of them we would measure in terms of grams, because none of them are very large or very, you know, we can tell that they're not very heavy. When trying to determine the mass of an object, it is important to think about how big it is, but that isn't the only thing to consider when figuring out the mass of an object, because we're going to see on the next page how some objects can be about the same size, but still have different weights to them. It just depends on if it is a solid object or what it's made out of, or if it's hollow inside, then it's going to be lighter. So we'll talk about that a little bit later. Okay, so which of these items do you think is going to have the greatest mass? I'm thinking out of all of these, actually a stapler, simply because staplers typically have sand down in the bottom of them to kind of weigh them down a little bit more. After the stapler, let's see, let's cross off stapler. What do you think would be the next heaviest item? Crayon, eraser, a marker, small notepad, or scissors? Well, it depends if you're talking about kid scissors or adult scissors, but I think I'm going to go with the scissors next, because scissors are typically, you know, made of metal, especially adult scissors. They're kind of big, so they would typically be heavier than these other items that I see. And again, we're just guessing because we don't have the correct tools to really measure the mass of these items and be sure. So we've got a crayon, eraser, a marker, and a notepad. I'm thinking now the notepad would probably come next. You know, it's got some paper in it. So after the notepad, what do you think? A crayon, a eraser, or a marker? I'm thinking probably the marker, because typically markers are bigger than crayons. So then the crayon would be my next item. And then after that, the eraser. And I was just kind of going by the size of the items, and my best estimate from having held these items before in my life, just kind of, I don't know, giving a good guess as to the greatest mass down to the least. All right, well, the next one gives us a nice picture, so we can answer this question of the share and show. If we have 5 bananas on this scale, what is the mass of the bananas? Meaning, how much weight does it carry? Now, when we look at the scale, notice how the balance scale is balanced. You know, it goes straight across. And we can see on the left-hand side of the scale that there is 1 kilogram weight. And so because it's balanced, we would say that the bananas have a mass of about 1 kilogram. And kg is the abbreviation for kilogram. Okay, sometimes it might be pronounced kilogram or kilos. It's the same thing. Okay? All right, over to the next page here. It says to choose the unit you would use to measure the mass. So gram or kilogram. So if we just have 1 strawberry, would we measure its weight in gram or kilograms? Well, strawberries are kind of like grapes. So I'm going to say a gram for the strawberry. Now it might be like 5 or 6 grams in its actual mass, but it's not going to be enough to use kilograms. How about a dog? Even a small dog is going to carry more weight than about 1,000 grapes, or again, think of maybe a pineapple for a kilogram. So we would use kilograms to measure the mass of a dog. All right, down here we're going to use the scales to help us compare the masses of the objects on the scale. So for number 4, it looks like a bowling pin and a chess piece, and we would say that the mass of the bowling pin is what to the mass of the chess piece? Now we have to pay attention and notice that the bowling pin is going down the scale, and the scale is tilted, and the chess piece is up a little bit. So those are the clues that will tell us which object weighs more or less. And so since it says the mass of the bowling pin first, the bowling pin is more than the mass of the chess piece. It weighs more because it is being weighed down, whereas the chess piece is raising up. How about these other two objects for number 5? It looks like maybe some Hershey Kisses on the right-hand side. Oh, definitely not Hershey Kisses. Wow. I'm looking in my book, and those are like the little clips that we use in our grammar books. And I don't know, these pink things are probably erasers, block erasers. Wow. On my screen here, they really look like Hershey Kisses, and I was going to say those were like some kind of pink cookies. Either way, what do you notice about these two objects? Both sides of the scale are about the same. You see how they're at the same level. So the mass, oh, I guess it tells me the problem. The mass of the erasers is the same as the mass of the clips. Because the scale is balanced, then the two objects weigh the same. All right, on your own here, but let's go ahead and continue this together. Would we use grams or kilograms to measure the mass of a chair? Boys and girls, these are like old school desks. I remember having to sit at a desk like this. We didn't have nice compartments to put our stuff in. Some of my classes did, however, I do recall sitting in some desks like this, so be lucky. Anyways, we would use kilograms to measure a chair. Sunglasses. Think about when you have sunglasses on in the summertime. Are they like really heavy on your face? Hopefully not, so we would use grams. Now, a watermelon. If you've ever tried to carry a watermelon, they are pretty heavy. Considering, so we certainly would use kilograms. All right, and then 9 and 10, again, we're using these scales to help us compare the masses of the objects. So for number 9, we have a pen and some paper clips, and since I see that the scale is at the same level, I would say the mass of the pen is the same as the mass of the paper clips. Now when we go to number 10, we have some straws on the left and some blocks on the right. And I notice how the straws are up a little higher than the blocks, so it's not balanced, they're not the same weight. We would say the mass of the straws is less than the mass of the blocks. The straws weigh less. All right. Moving right along, we are at our problem solving. And this is where I was talking about where we have to pay attention to not just the size of objects, but also what they're made out of, or, you know, thinking of our own real life experiences with some of these objects, because two things that are exactly the same size does not mean they are exactly the same weight. So we need to look at these sports balls and put them in order from the greatest mass to the least. So we're going from greatest to least. Now, when we do that, we need to kind of think of our own experience with these sports balls, but also looking at the size is important too. So we have a golf ball, a table tennis ball, which is like a ping pong ball, a baseball, a tennis ball, and a bowling ball. So thinking of your own knowledge about these sports balls, or even if you aren't sure of a couple balls, maybe you've never held one before, played with one, let's look at the size. The largest is clearly the bowling ball. And I do know from having gone bowling before that bowling balls can be quite heavy, and they would be heavier than a golf ball. Because I know you have to hit a golf ball with a club, and if it weighed more than a bowling ball, I'm pretty sure your club would break. Table tennis, I know, is a very light ball. Baseballs can be heavy, but certainly not as heavy as a bowling ball. Otherwise, your bat would break every time you would swing and hit the ball. And then a tennis ball, I have played tennis before, so I know tennis balls are not as heavy as bowling balls either. So the bowling ball would be the heaviest in its mass. Now after the bowling ball, we've got 4 balls left, and 2, they kind of like have the same size here, these two, the golf ball and the table tennis ball, but then also a baseball and a tennis ball seem to be the same size too, but they don't necessarily weigh the same. So I'm going to go to the next 2 balls that are greater in size, so the baseball and tennis ball. So let's just compare those two. Out of baseball and tennis, I know from my own experience that a baseball weighs more than a tennis ball. Because, you know, when you are playing baseball, typically nowadays you use a metal bat, so it has to be pretty sturdy to hit. And then when you play tennis, you're just using a racket, so it's not as heavy of a ball. So then that we got those 2 checked off our list, we have the golf ball and the table tennis or the ping pong ball. Now, I have golfed before and I have played ping pong. Even though these 2 balls are about the same size, they do not weigh the same. Golf balls you hit with a club, and usually they're metal also. And then table tennis, you're playing on top of a table and you're using those little paddles. So a golf ball is going to weigh more than a table tennis ball. Golf ball and then table tennis ball. So even though I don't have a scale, I can, put those items in order of their mass from greatest to least, just from my own real world experiences with those items. All right, now number 12, it says to use diagrams. Choose 2 objects that have about the same mass. Draw a balance scale with one of these objects on each side. So we're looking for the same mass. So I thought ahead of time here, and a bag of sugar and a bag of flour to me would be about the same mass. So you could do a balance scale just like I am here, nothing fancy, just making little platforms where they're sitting on, and they're at about the same height. If you can think of 2 objects that are about the same in their weight, maybe like our math book and our reading book, they would probably have about the same mass. Or maybe a gallon of milk and a gallon of orange juice would have about the same mass. Okay? Don't spend a whole lot of time there. Again, it's kind of hard to, answer these questions when we don't have our scale to practice on. So then number 13 wants us to find two objects that actually have different masses and to, again, draw a balance scale showing the weight of the two objects. So I, again, thought ahead of time here, and I picked a fish and a dog. And a dog is going to weigh much more than a fish, even if it's a small dog. Whoa, just drew all over him. And a fish is going to have less mass. So on my balance scale here, I'm showing that the dog is weighed down. And actually, I should slant this part. It doesn't have to be perfect. There we go. That looks a little better, huh, Mrs. Jockel? Good job. All right, so then we can see that the mass of a dog would be more than a fish. Now for number 14, we need to write a problem about the objects that you chose in exercise 13, then solve your problem. So for number 13, I did the dog and the fish for my two objects that had different masses, and so they just want us to write our own question now. So I might say, oh my gosh, I really cannot type. Which animal has a greater mass? And from looking at our scale, we can answer this question. The dog's mass is greater. Okay? So they just wanted us to come up with our own question. Nothing fancy about it. Now on number 15, it is a think smarter, sense or nonsense. And this is actually a math on the spot, and we are going to watch the video because this does have us think a little bit. But first, let's look at the problem. It says Amber is buying produce at the grocery store. She says that a Fuji apple and a green bell pepper would have the same mass because they are the same size. Does her statement make sense? Explain. Now, I might think right off the bat very quickly, well, yeah, that makes sense because they are about the same size. When you think of a green pepper and an apple, yeah, they're about the same size. But we cannot just consider the size of objects when we're trying to calculate their mass. So let's take a look at the video and see how our math friend explains to us if this makes sense or not with what Amber is saying. So sit back and enjoy the video.
Well, welcome to the Math Cooking Show. I'm your host, Professor Berger, and I've got something special in store for you, and it involves this apple. But first, I wanted to ask you a riddle. Let's check it out together and then see what we think. Now, Amber is buying produce at the grocery store. Now, she says that a Fuji apple and a green bell pepper would have the same mass because they have the same size. And the question is, what do we think about her statement? Well, let's take a look together and see what we think. So here's the Fuji apple, and here is the green bell pepper. And as you can see, they do seem to have the same size, and so she concludes, therefore, they're going to have the same mass. But remember that mass is the amount of matter that an object has. So it's not just solely based on the actual size. So how much matter is in the Fuji apple versus how much matter is there in the green bell pepper? Well, one way to actually see that for ourselves is to actually cut them open and see what we see inside. And so I'm going to try to do that right now. Since it is a cooking show, I think it's okay, and I've got permission to use these knives, so it's okay. These great plastic knives. Okay, so you ready? Here we're going to go. I'm going to try on the count of 3. I'm going to cut them both in half. Are you ready? Don't try this at home. Here we go. 1, 2, 3. Yeah! Aha! Now, when I look inside, I see that there's lots and lots of matter in the Fuji apple. But notice that the green bell pepper is really hollow. There's lots of spaces in there. And so that tells me that there's more matter in the Fuji apple than the green bell pepper. Since, in fact, the apple is solid And so therefore, the masses are not the same. And so what we can conclude is that while Amber had a really good type of thought, she has to remember that, in fact, when we're talking about mass, it's not just size. So just because the two produce are the same size doesn't necessarily mean they have the same mass. In this case, the mass of the apple may be greater because it's solid inside. So very tricky to realize that there's a difference between size and mass. Well, I hope you enjoyed this episode of Cooking with Professor Berger. And the next time that you want to simultaneously cut up both a Fuji apple and a green pepper at the exact same time, I hope you remember to call on me. Have fun thinking about math, and we will see you soon.
All right, I had no idea his name was Professor Berger. How about his cutting skills? Anyways, so does Amber's statement make sense that the apple and the pepper have the same mass because they are the same size? Well, as Professor Berger showed and demonstrated, this does not make sense because, what did he say? No, just because two objects are the same size does not mean they have the same mass. Oh, wow. The apple may have a greater mass because it's solid. So when you think about that, that actually makes sense. Apples are solid, but then when you cut a pepper, you have a lot of hollow space. And so a pepper would not weigh as much as an apple. So when we're thinking about the mass of items, we cannot just think about their size. We have to consider, like I mentioned, what they're made out of, and use that to kind of help us gauge how much mass they have. All right, so go ahead and get that written down. If you need a few extra minutes here, go ahead and pause the video. Otherwise, we are on number 16, our Think Smarter. We need to select the objects with a mass greater than 1 kilogram. Select all that apply. So remember, 1 kilogram is equal to 1,000 grams. Okay, so 1 kilogram, 1 kg equals 1,000 grams. Now, a gram is, like I said, a grape. Think of a grape for grams. And a kilogram is kind of like a pineapple. So what would be heavier than a kilogram, than a pineapple? Would a skateboard? Yeah, skateboards are large in size, but they're also kind of heavy too. How about a laptop computer? Yeah, laptop computers, carry a lot of mass to them. I mean, they're not heavy where you're like, your arms are dragging to the ground, but you can still feel their weight. How about a cell phone? A cell phone, I would say no. We would measure the weight of cell phones in grams, because when we're holding a cell phone to our ear, it's not like, real heavy in our hand. How about an egg? 1 egg, definitely not heavier than a kilogram. A desk? Yes, a desk certainly would be. How about a pencil? No. Okay, so those 3 items would be heavier than a kilogram. They'd have a greater mass. All right, guys, now we are on to the practice and homework page already. So we need to tell if we would measure these items mass using grams or kilograms. So a CD, we would use grams. To measure the mass of a boy or a girl even, we would use kilograms because we're pretty heavy. A bag of sugar, what do you think? Sugar is teeny tiny little specks of grains, but no, a bag of sugar is pretty heavy, so kilograms for the sugar. Alrighty, down here looking at our scales, we need to compare the masses of the objects. So we have a candle and a light bulb. And pay attention, is the scale balanced? Is it leveled out? No, the candle is down farther than the light bulb. So that tells me that the mass of the candle is greater than the mass of the light bulb. It weighs more. And when we look at number 5, we have a watch and a necklace. I see that the scale is leveled. It is balanced. So the mass of the watch is the same as the mass of the necklace. They are the same. All right, down to our problem solving. A red ball has a mass that is less than 1 kilogram. A blue ball has a mass of 1 kilogram. Is the mass of the blue ball more than or less than the mass of the red ball? Well, it seems kind of tricky, but really they kind of told us the answer because let's highlight some things here. Okay, so the red ball has a mass that is less than a kilogram, and the blue ball has a mass of 1 kilogram. So the blue is 1 kilogram, the red is less. So if the red is less than the blue, that means the blue is more than the red. They just try to word it so tricky, but they can't fool us. All right, number 7. Brock's dog is a collie. To find the mass of his dog, should Brock use grams or kilograms? Well, dogs weigh a lot, even if they're small, so kilograms. Okay? All right. Number 8 is kind of hard to do again since we don't have scales to kind of balance out the mass of items, but it wants us to name an object in our home that has a mass of about 1 kilogram. So I'm going to say a pineapple just because that was what I was using in my examples of thinking grams are equivalent to grapes and a kilogram is equivalent to a pineapple. Moving along, lesson check. Which unit of measure would you use to measure the mass of a grape? Ha, told you guys. Grapes would be measured in grams. And number 2, Elsie wants to find the mass of her pony. Which unit should she use? Like, right, gram or kilogram? Even though a pony is not a full-grown horse, you would use kilograms. Alrighty, 4 left to go. Spiral review. Marcy blew up 24 balloons. She tied the balloons together in groups of 4. How many groups did Marcy make? Okay, so this is a division problem. She had 24 balloons and she divided them into groups of 4. She put 4 balloons together in a group and then 4 more in a group. And so how many groups can she make out of 24 balloons? Well, 24 divided by 4 equals 6. So she has 6 groups of balloons. All right. Number 4, Clark used the order of operations to find the unknown number. In 15 minus 12 divided by 3 equals n. What is the value of the unknown number? Ooh, do you remember how we always do multiplication and division first, and then addition and subtraction? So we are going to start by looking at 12 divided by 3. And what does 12 divided by 3 equal? 12 divided by 3 equals 4. And so then we do 15 minus 4, and that will equal n. And 15 minus 4 equals 11. Okay? All right, so we need to use the pictures of the bottles here to answer number 5 and 6. Which bottle has the most amount of juice? So when we're talking about metric capacity, remember we learned about liters in lesson 7. So which one has the most amount of juice? So which container seems to be the most full. I'm saying bottle. Whoop, way over here. Bottle A. And which bottle has the least amount of juice? Bottle D. All right, boys and girls, we have one more lesson in chapter 10 that we'll be doing tomorrow. Next week, we are moving into chapter 11. So I am kind of just skipping over the end of chapter review for chapter 10. You are more than welcome to do it for extra practice. But in order to kind of stay on track and finish with our next chapter by the end of our distance learning from home, we do need to get started into chapter 11. And since we aren't taking an actual test, it's okay that we don't do a full chapter review. But like I said, you are more than welcome to go ahead and complete that. I encourage you to do so just because chapter 10 is so important with measuring length. And we talked about time at the very beginning, and there is a review on time on my Google Classroom page under math resources that Mrs. Van Wart put together and shared with us. So check that out, but I hope that you tune in tomorrow for our next math lesson. Have a good day.